So this summer, my family and I, we didn't want to go to the ordinary fireworks show and fight all that traffic, right? So we just set off explosives in our front yard. It was awesome. A couple times though, they were a little too close and we kind of had to scoot back, right? You want to make sure when a firework goes off that it's nowhere near you. Just how do we figure out when that firework is going to explode and how far away it should be, right? Especially if you're at a professional show, they make sure that you're safe, right? How do they do that? Well, it turns out it's all about projectile motion. They need to time those explosives so they go off when the firework is at the highest point, and they need to know that it's far enough away from you. Let's take a look at all the math we can do to understand just when fireworks should explode. Let's learn. First, let's review our lesson objectives. We'll start by explaining the steps needed to solve projectile motion problems. These are basically problems where we're throwing something in the air. Then we'll show that the vertical velocity in these problems is 0 at maximum height. You may have no idea what that's saying, and that's okay. We'll dive into that in just a moment, and it'll be totally clear. Then we'll practice solving projectile motion problems. Just a reminder, these problems come from the TEAS physics textbook, which you can Google online and access for free. All right, what are the steps we're going to follow to solve these problems? First, we'll sketch the problem and identify the directions. Most importantly, which direction represents X, the horizontal direction, and which direction represents Y, the vertical direction. Then we'll split the knowns that we're given into their X and Y components. So oftentimes you're given the velocity, and you'll find the velocity in the X direction and the velocity in the Y direction. Next, we'll list our knowns and unknowns so that we know what info we have and what we're looking for. That's going to help us in step 4, where we identify the relevant equations. We'll go through our equations and we'll say which one of these has just one of our unknowns and the rest of the things we know. That's the equation you need. Then we'll solve for those unknowns. Okay, let's jump into a problem. This one says a firework is shot into the air at 70 meters per second and an angle of 75 degrees above the horizontal. The fuse is timed to ignite the shell just as it reaches its highest point. At what height does the shell explode? Well, here we need just a little more info to solve the problem. So before we move forward, let's consider the velocity at the highest point. These are dumplings. Why am I showing you dumplings in a physics video? That's a good question. Well, they're being thrown in the air, and something really important happens as they reach their maximum height. Just for a moment, their velocity in the vertical direction is 0. Let's watch that one more time. The velocity is going up, 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 slower, stopped, then down, down, down. This teaches us a really important fact. At the maximum height, the velocity in the Y direction is 0. So here's the key fact you need to know. At the maximum height in our problem, or the maximum displacement, the velocity in the Y direction is equal to 0. So now let's dive back into this problem, knowing that the velocity in the Y direction at the highest point is now 0. Now we'll be able to solve this. We should start by drawing it. So basically here we have a firework being launched into the air, and we're told that the angle it's launched into the air at is 75 degrees. Further, we're told that the velocity is 70 meters per second. So we know this firework is going to go up into the air, and at some point, its highest point, it's going to explode. Okay? And now we know the velocity when it explodes. And what this problem is asking us to find is its height. What height will it explode at? So basically, that's asking us to find Y final, the final height there. All right, so that's kind of a rough sketch of what we have. And now what we're going to do is to split up our velocity into its components. In this case, because the problem is asking all about the Y direction, we're going to solve for the Y component of velocity. So remember that that's equal to the entire velocity times sine of the angle. So in this case, we're going to have 70 meters per second times sine of 75. That should give us 67.6. And I'm going to put some dots there to help us remember that that number shouldn't be rounded until the very end. So that's our initial velocity in the Y That's the initial velocity going upwards. Now that we've split it into the components that we need, let's identify any other important knowns. Well, we also know the velocity y final, that's 0. And we know that the initial height that we start at is 0, and what we're looking for is that final height. So go and look through your equations. Do you see one that connects velocity final, velocity initial, y initial, and y final? Yeah, well, the best one to use here is that velocity y final squared equals velocity y initial squared minus 2g times y final minus y initial. And in this case, some of these variables we already know are 0. For example, the final velocity is going to be 0, and we know the initial position is 0. That simplifies our equation right away to 0 equals velocity in the y, initial squared, minus 2gyf, because that y0 just fell out. And what we want to do now is to try to isolate y final. That's what we're actually looking for, is this guy right here. So the first way to do that is to go ahead and get y final on the other side. And so we're going to add 2g y final to both sides, and we'll get 2g y final equals vy0 squared. And now we want to isolate that y final. We'll do that by dividing both sides by 2g. So when we divide both sides by 2g, what that does is it cancels out the 2g on the left, so we'll get rid of that, and leaves us with just y final on the left. Now we're ready to go ahead and solve for y final. We're going to plug in the initial velocity in the y direction. That's at 67.66. And we're going to square that. And we'll divide that all by 2 times gravity, which is 9.8. Now remember, here's where you want to make sure and use that whole 67.6 number that we have in our calculator. When we plug that in, we should get 233. And because we have just 2 sig figs in our angle, we're going to round that to 2 sig figs here, and that 3 tells us we should round down. So we're going to round 233 to 230 meters. So that's the height at which our firework is going to explode. Great, let's do one more. This problem has to do with the same circumstances we just saw. Only now we're told that the fuse is timed to ignite the shell at a height of 233 meters. And what we want to know in this case is how long did it take to reach this height? We already know what this picture looks like, and we've already found our y component of velocity. So let's go ahead and list some other things we know and jump right into solving this problem. We still know the velocity y initial is 67.6 ... meters per second. Still want to keep that whole value in our calculator. We know that the velocity y final is still 0 when it reaches that maximum height. We also now know that the final height in the y direction is 233 meters, and that the initial height is, of course, 0 meters. It starts on the ground. And what we want to solve for in this case is time. So we want to know what time it will explode at. So what we should do is check out our equations and see if there's something that links these variables but has time in it as well. The best equation to choose here is velocity y final equals velocity y initial minus gt. This equation is basically saying take your initial velocity in the y direction and subtract gravitational acceleration multiplied by time. So we already know that our final velocity in the y direction is going to be 0. So that drops out. And we get 0 equals velocity y initial minus gt. We want to solve for t here, so we're going to go ahead and start by moving that g times t over to the other side and get g times t equals velocity y initial. All we did there is add gt to both sides. What should we do to isolate t? Well, we should divide both sides by g. When we divide both sides by g, these g's will cancel, and what we'll get is that time is equal to velocity y initial divided by g. So in this case, time is equal to 67.6 ... divided by 9.8. When we plug that into our calculator, we should get 6.899 and so forth. Now here we're going to round again to 2 sig figs because our angle has just 2 sig figs, and we'll get time equals 6.9 seconds. So it takes 6.9 seconds for that firework to reach that maximum height of 230 meters. One last projectile motion problem here to practice. Let's take a look. This problem says a firework is shot into the air at 70 meters per second. Sounds familiar, right? above the horizontal. The fuse is timed to ignite the shell at 6.9 ... seconds. What is the horizontal displacement when it explodes? Okay, this is your chance. Pause the video, draw another picture. This one's going to use the X variables, just a hint, and see if you can work it out. Okay, did you get it? Let's draw it first. Once again, we still have our firework being launched into the air at a 75-degree angle. And we know that velocity is 70 meters per second initially. We know that our firework travels up into the air and reaches some maximum height where it explodes. And we now want to know the horizontal displacement, so that's this direction. That means what we're going to need to start by finding is that velocity in our x direction. So we need to know what our velocity in the x direction is equal to initially. So we've drawn a picture and we've realized that we need to solve for that horizontal direction. And so we're going to split our velocity up. Remember that our velocity x initial is equal to our velocity initial times cosine of our angle. So what do we get there? Well, we're going to plug in 70 times cosine of 75. And what we'll get for our velocity in the x direction initially is 18.117 ... So again, just holding on to all those digits in our calculator before we round. All right, well, in the x direction, what else do we have? We know that we want to solve for x final. And we know also x initial. Where should we say it is at x initial? Well, right, the firework is starting at what we'll call 0, 0. So this is going to be 0. And we also know, in this case, our time, right? We know that that's our 6.89 ... seconds. So we need to go and use our x equation. This is really straightforward because there's only one x equation to grab. It's x final equals Vx times t plus x0. And in this case, we know already that our x0 is 0. So we just reduce that to x final equals velocity in the x direction times t. And now what I'll do is I'll plug in that velocity in the x direction that we found, which is 18.117. And there's some other stuff there that we'll add in our calculator, times the time, which is 6.89, and some other stuff that we should also keep track of in our calculator. When we multiply those together, we'll get 124. And that 4 means we're going to round down, again, to 2 sig figs. So we'll go to 120 meters. So to 2 sig figs, we know that the x final is 120 meters. Let's review what we've learned. We've explained the steps needed to solve projectile motion problems. Keep those steps handy as you look at all the problems that you need to do. Then we've showed that the vertical velocity is 0 at maximum height. Basically, whenever you throw something, before it can come back down, it has to stop and go at exactly 0 meters per second. So it goes up, 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 stops, there the velocity is 0, and then down. We then practice solving projectile motion problems from the TEAS physics textbook.
Hey, hey.